Hello everyone, welcome back to my YouTube channel. Again, this is Sir Robinson, your partner in learning mathematics. In this video, we are going to learn about the theorems on differentiation. I assume that all of you know what differentiation is. Differentiation, that is a process in finding the derivatives. And derivatives, that is the rate of change. So before we proceed in this video, let's try to review some of the special concepts that we've learned last video. As if you still remember, this is the limit definition of a derivative. Do you still remember this one? This is the limit definition of a derivative. In finding the derivative, you have to get the limitation of somehow, it's complicated, I know, that makes your life complicated last week. And in this video, I'm going to teach you how to solve derivatives of a function in the most easy way possible. So before that, also remember that we've discussed these notations. These are the notations that give emphasis on things about derivatives. This gives emphasis that we are getting or we are solving the derivative of a function in different notation. It could be f prime of x, y prime, dy over dx, and so on and so forth. In this video, do not be confused because I'll be using these notations in all aspects in solving the derivative of a function. I do hope that you'll take down all of this, you will not be confused later on. Okay, so without further ado, let's solve the derivative of a function. The rules of derivative of a function. After this video, we'll no longer use the long version in solving the derivative. We're going to use these theorems and rules to make derivatives fun and easy to do. So the first rule is that the constant rule. So what is the constant rule? For formality's sake, the definition is that for any constant k, let f of x equal to k. In short, we are dealing here a constant function. Meaning, when we say constant, that is, in layman's term, we are dealing with pure numbers, only numbers. The question is, what is the derivative of any constant or any number function? So the derivative of a constant function is 0. This is applicable to all constant function. This is applicable to all equation which is only purely number. Okay. So let me give you this example to have this clearer picture. Say for example, I have f of x equal to 35. The question is 35 a constant? Indeed, 35 is constant, therefore its derivative is 0. Again, it is applicable to all. What is the best way to explain that the derivative of a constant is 0? Take note that we are dealing derivative. When we say derivative, we are dealing with changes. When we say constant, it is no longer, or it is not associated with change. When you say that the constant is changing, that is impossible to happen. That is why the derivative of any constant or any number in your function, in your equation, that is always equal to 0. That is constant rule, and that is a theorem already. Let's try to have more example to have a clearer picture on how the constant of a function works, or the constant rule in derivatives. So say for example, I have f of x is equal to 5. Since 5 is a plain number or a constant itself, therefore its derivative or the derivative of 5 is 0. Next, f of x is equal to pi. Is pi a number? Is pi a number or a constant? Yes. In our mathematical journey, we believe that pi is a constant. Therefore, in getting its derivative, the derivative of pi is equal to 0 because pi is a constant. Take note, as you can observe here, I am using this notation and also this notation, d sub x and d over dx. But I am I am referring to the same thing, which is the derivative of a function. Next is f of x is equal to negative 4. Is negative 4 considered to be a constant? Yes, that is a number with a negative sign. So meaning that is still a function. That is still a constant further. Therefore, its f of prime of x is 0. Lastly, f of x is equal to 4 over 5. Still, 4 over 5 is a constant or a number. Therefore, its y prime is equal to 0 or its derivative is 0. The point is, every time you deal any number only of a function, once you get its derivative, automatically the derivative is 0. Again, it is applicable to all numbers. And again, take note, I am using different notations here. D sub x, d over dx, f prime of x, and y prime. I am using different notation, but I am referring to the same concept, which is the derivative. Do not be confused with that one. And that is constant rule, ladies and gentlemen. Let's try discussing the second rule of the derivatives, which is the identity rule. What is now the derivative when we deal identity in our function? When we say identity, we are referring only to a single variable, or shall we say a single variable x, considering that x is our independent variable. What is now the derivative of a single variable as a function? Let f of x is only x, then I have here f of x is equal to x. Of course, x is not a constant. That is a variable, a single variable. Therefore, identity rule is more appropriate in using or in finding its derivative. What is the derivative? Let's take a look at this one. There you have it. The derivative of a single variable is 1. That's how identity rule works. In short, once you deal identity, whatever number beside that single variable x, in my example, I have an invisible 1. Therefore, its derivative is 1 because that's the number beside your single variable x. I have here more examples to have a clear picture on how identity rule works in finding the derivatives. Example 1, f of x is equal to 2x. Obviously, that is not it is not appropriate to use the constant rule because 2x is not plainly constant. We have a variable beside which is x, a single variable. What is now the derivative? The derivative of 2x is 2. Because the derivative of x is 1, since I have a constant beside it, I have to multiply it to the derivative of x, which is 1. 1 times 2, that is 2. Next is f of x is equal to pi x. Single variable x and a constant pi. Same thing with example number 1. The derivative is whatever number beside a single variable. What is my constant in this form? The constant is pi. Therefore, the derivative of pi x is equal to pi. Third one is the derivative of negative 4x. Identity rule is still appropriate for example number 3, simply because I have a single variable x and a constant negative 4. What is the derivative? The derivative is negative 4. For last number, f of x is equal to 4 over 5x. Still identity rule for a single variable x beside 4 over 5. What is now the derivative? The derivative is 4 over 5. In short, identity rule works when you encounter a single variable in your function with a number beside it. If that happens, therefore, the derivative of that function is the number beside your single variable. In my example, whatever number beside x, that's the derivative using identity rule. That's how identity rule works. Okay, we are now down to the third rule for the derivative. This is called the general power rule. Obviously, this is called power rule because we are going to deal with functions whose exponent is greater than 1 or negative or in a fraction form. Okay, so let's try to look at this one on how it works. Okay, for any real number n, where n is exponent. So n here is an exponent, and that is good for any real number. Meaning, it could be positive, negative, or in a fraction form, for as long as that is an exponent and that is a real number. So take a look at this example on how general power rule works. So I have here f of x equals to x squared. So obviously general power rule is appropriate simply because my function is or has an exponent not 1. So what we're going to do is observe this form now. Look at this now. So from x squared it becomes 2x2 minus 1. How it happens? Simply what this form happen is your exponent is being bring down here as a base. That is why it becomes 2. Since you have 1 here, so you multiply your exponent 2 times 1, that is now 2. And after you do that manipulation, you deduct 1 to your power. So it will become f prime of x equal to 2x1. That's how general power works. Question is negative 1 should be applied to all. Yes, that is constant. You have 2 minus 1 when using or deduct 1 when using general power rule. Okay, so I have here my example to have a clear picture on how general power rule works. So say for example f of x equal to 2x squared. So what we're going to do, you multiply your power to your base down here. So that is 2 times 2. That is now 4. And you have to deduct 1 to your exponent, which is 2. So you have to put some negative 1 down here. So 2 minus 1. That is why I have here is 4x raised to 1. So that's how general power works. More example to have understanding. So f of x equal to 5x raised to negative 3. Question is, since I have here a negative power, is general power still appropriate? Yes, because negative 3 is still in the number line and that is still a real number. So meaning general power rule is still appropriate. The same thing, what you're going to do is you multiply your exponent to your number here, and I have a number pi. So negative 3 times pi, that is negative 3. So it becomes like this. Again, negative 3 times pi, that is negative 3. And same thing, for example, number 1, you have to put minus 1 to your exponent. So negative 3 minus 1, that's why it becomes negative 4. Same sign, you have to add and copy the sign. So obviously in this form, my exponent here is negative. In mathematics, we don't usually end with a negative exponent. We usually convert that negative exponent to the positive one. How? By putting or by getting its reciprocal. So meaning it will become now something like this. Negative, this negative is from the negative 3 pi, and you put x raised to negative 4 to the denominator, or you get the reciprocal to make it positive. Okay, so again, if you encounter exponent as an answer which is negative, you have to get its positive, or you have to get its reciprocal by putting it in the denominator. So do not end with an answer with a negative exponent. Okay, good. So let's proceed more to how general power rule works. So for general power rule works, f of x equal to negative 4x cubed, same thing. Exponent, a layman's term, exponent multiplied to the base down here, so negative 3 times negative 4, that is negative 12. And you have to put minus 1 in your power. So 3 minus 1, that is 2. So meaning the derivative, or f prime of x is negative 12x squared. Okay, for example number 4, 4 over 5x raised to negative 3. Still, negative 3, our general power is still appropriate because negative 3 is real numbers, so we can use general power rule. Same thing, your exponent, which is negative 3, should be multiplied to the number beside. And my number beside here is 4 over 5. So 4 over 5 times negative 3, that is negative 12, or 4 times negative 3, negative 12 over 5. And same thing, you have to put minus 1 down here. So negative 3 minus 1, that is negative 4. Obviously, observe this one, my exponent, I have an exponent which is negative. What I did with same with example number 2, I have to convert or get the reciprocal or put that one in the denominator. So by putting that one in the denominator, it will become negative 12 over 5x to make it positive. So therefore, that is now the derivative of example number 4. And that's how general power rule works. You know your exponent, you multiply that one to your base, and you deduct your exponent by 1. And that is constant, and that is applicable to all. That's how general power rule works. Okay, so I hope everything is clear. That's the first 3 rules for theorems of differentiation. First is the constant, identity, and the general power rule. More to go for the next video.